Hello everyone, I'm Debarshi Burman from Delhi Public School Numaligarh, and we have collaborated with Army Public School Jorhat to make an IoT based system for smart farming. We all know that improper irrigation leads to reduced yield and poor quality of the crop, and as a result the farmer has to face huge losses. To overcome such problems, we have made a project which is an IoT based system for smart farming. In this project, I have implemented the temperature and humidity sensor, which will sense the atmospheric temperature and humidity levels and will send it to the ThinkSpeak cloud via the Node MCU. Now the rest will be explained by my friends from Army Public School Jorhat.
Hello, myself Gaurav Hazarika from Army Public School Jorhat, and we have selected the theme Energy from Energy and Transportation. Today I am going to explain about the problem statement and our own proposed solution. India is an agrarian economy with 50% of population in the agriculture related sector. From our research, we have found that 54% of land in India is arable and 46% of the land in India is not arable. Unfortunately, 20% of crops get destroyed due to excessive sunlight and 54% of crops get destroyed due to flood and rainfall. Excess sunlight dries up the surface of the soil and can lead to drought, which destroys the crops. Also, excessive irrigation can also damage the crops and remove the top fertile layer of the soil, which destroys the nutrients in the plants. To prevent this, we have come up with a solution, our IoT-based smart farming system. Our solution prevents the destruction of the crops due to excessive sunlight and controls irrigation of crops and monitors humidity and temperature of the surrounding. My contribution in the system is that I have configured the working of the LDR sensor and the servo motors. Thank you.
Hello, myself Sharad Chetia from APS Jorhat, and I am going to explain about the technical details and function of the system. So, there are a lot of components here. So we have Node MCU and relay, a rain sensor, DHT sensor, 2 servos, 1 submersible motor, and LDR sensor. As you can see here, this is the submersible motor and this is the moisture sensor. So when I power up the system, this will automatically start working because it will not sense enough moisture in the soil. But when I put it in an area where there is enough moisture, it will automatically stop. So I am powering up the system. So you can see the motor have already started and it should stop in a moment. This is the rainfall sensor, and it detects whether it is raining or not, and it also stops the submersible motor automatically whenever there is a heavy rainfall. This is the LDR sensor, and as Gaurav have said that excess of sunlight can destroy the crops, so we have programmed this system in such a way that the Node MCU will detect the sunlight and it will automatically command the servo motors to close the shed. That I am using a light source as the flashlight. So when I bring it closer to the LDR sensor, so you can see the shed have automatically closed. But after 5 seconds, see. So if I bring it closer again, it's closing it again. This is the DHT sensor, and it is providing us with real-time data of temperature and humidity in the surrounding. And all the information and all the data that is given by these sensors are sent to the cloud and is easily accessible in any part of the world. The system is very user-friendly and highly upgradable and cost-effective with very low maintenance cost. This system can be used with different kind of crop and can be used for a long term. This will definitely benefit the farmers and will help the environment by preserving resources. Thank you.